Welcome to By Excellence Tutorials, and in this video we are going to solve a question from static equilibrium, that's physics. So a question reads, a uniform ladder of mass m rests against a frictionless vertical wall at an angle of 60 degrees. The lower end rests on a flat surface where the coefficient of static friction is 0.4. A student with mass m equal to 2m, okay, this capital letter M, attempts to climb the ladder. What fraction of the length of the ladder will the student would have reached when the ladder begins to slip? Okay, so I have tried to sketch the situation. I have tried to sketch the scenario, and then I have the mass of the ladder, which is mg, and then the mass of the ladder m, which is now finding the weight we calculate by the gravitational acceleration, and then is at the distance half of the ladder. And also we have this student that has climbed a distance that we don't know, which is x. I've labeled it to be x, and with mass 2m. And the weight of this student is going to be multiplied by the gravitational acceleration, which is going to be 2mg. So we also have to identify the forces on this system. So we have the normal force here at the end of the ladder, and then at the foot of the ladder, and we also have the friction force, because we see that the friction force will be in this direction, okay, because it's more like it's preventing the motion or the ladder from sliding. And then at this point in the vertical, we also have the normal force. This is the normal force, okay, at the wall. This is here is the normal force at the floor, okay, the force that the floor is exerting on the ladder, and this is the normal force that the wall is exerting on the ladder as well. So when we identify all those, we now consider the Newton's, okay, laws of motion, or second law of motion. Now here we don't have motion, so the summation of all the forces in the x must be equal to 0. We don't have motion. This is static equilibrium. So we look at the forces in the x direction. So the only forces that we have the friction force, and then we have minus this normal force that is being exerted on the ladder by the wall, which is F with the subscript W to symbolize that is wall, are the only two forces acting on this ladder. So this should be equal to 0. So friction force is equal to that. And this, let this be equation 1. And then we go to also the summation of forces in the y also should give us 0. So now, these forces in the y, we have the normal force, okay, that the ground is exerting on the ladder, pointing in the positive direction. So we have normal force. And then the other two forces we have here, the weight of the ladder, and also the weight of the student. So now we have minus mg. This is the weight of the ladder, and also minus 2mg, the weight of the student, give us 0. So you can say that we have Fn minus 3mg being equal to 0. And the normal force is actually 3mg. Okay, so this is our equation 2. Okay, so now we've done with the forces, and then we have to look at the torque. We need to find the torque. So also conservation, we have the summation of torque should also be equal to 0. So we pick this end to be our pivot point, meaning all the forces acting on this point or at this point will be equal to 0. So the remaining forces that we're going to have is the weight of the ladder and the weight of the student and the normal force the wall is exerting on the ladder. So we have, we have the normal force and the perpendicular distance from this point to where this normal force is. We see that it is this distance, which is equivalent to that distance. So we have the angle 60 here, and this distance trigonometrically, we are going to see that is going to be the length of the ladder times the sine of this angle. So we have length of the ladder, which is L sine 60. That will be the distance, the perpendicular distance. And then, so we have minus in the sense that these other two forces are pointing in the opposite direction to that one. Okay, so we have mg, the weight of the ladder, and the distance, the perpendicular distance. Okay, so this is mg, the perpendicular distance is this one here. And what is this distance? So we have the more like hypotenuse here, which is L over 2, okay, half of the length of the ladder. And we have also the angle, and this is actually the adjacent. So it will be L over 2 cos 60. And then we also subtract the weight of the ladder of the student, which is 2mg. And then the perpendicular distance to that force is actually x. Okay, we have x and cos 60. So x cos 60 equal to 0. Okay, so now what we have here now is from equation 2. So let this be our equation 3. And from equation 2, we see that we can be able to find the friction force, because we know that the relationship between the friction force and the normal force is given by friction force equal to nu times the normal force. So we have nu of 3 nu mg. So this is the friction force. And this same friction force is same with the normal force at the wall, that the wall is exerting on the ladder. So we have, this is the same as also that. So we can substitute 3 nu mg in where there is Fw here. Okay. And what we're going to have is 3m ug L sine 60 minus mg L over 2 cos 60 minus 2 mg x cos 60. So this is equal to 0. Okay, so we can see something that is common here. Okay, and that thing that is common is m. Mg is common, so get rid of mg, and then we can also plug in now the values. So we have 3, nu is 0.4, and we have L sine 60 minus L over 2 or 0.5 cos 60 minus 2x cos 60 equal to 0. So we can punch that and we get so we get 1.04 L here minus, so we have cos 60 and then we are going to have okay. Here we have 0.25 L minus x equal to 0. Okay, so now what we have now is you can bring the x this side, and we have 1.04 minus 0.25 L, which gives us 0.79 L equal to x. Okay, so now we are looking at the fraction of the ladder. So we divide through 0.79, or sorry, we divide through L, because that is what is going to give us the fraction. So L, so what we're going to have now is x over L equal to 0.79. Okay. Meaning it's about 79%. Okay, so since we had let x to be the distance covered by a student, so the fraction is going to be the distance covered by the student, which is x, out of the length of the ladder is going to be, the fraction is going to be 0.79. So he is going to climb about 79% of the length of the ladder when the ladder begins to slip. So this is how you get to calculate or tackle such questions. Have you found this video to be helpful? If you have found this video to be helpful, kindly like the video, comment on the video, and you can as well share. And if you have not yet subscribed to the YouTube channel, kindly subscribe so that you get notified each time I upload a new video.